Hi everyone. Today I'll give you a quick overview of how we model price elasticities using 4 different approaches. Double machine learning, otherwise known as DML or causal machine learning, for causal inference, a linear log-log model, elastic net, or random forest. We start by collecting sales transactional data, competitor prices, promotions, inventory distribution, and many other external factors like stockouts or weather patterns. And we clean and prep the data, focusing on items that actually have enough price variation to estimate elasticity reliably. We typically look for at least 5% price variation. For the modeling process itself, in addition to including our own prices, of course, we include promotional activities, we include competitor actions, seasonality, distribution, so we can isolate the true drivers of demand. Once we do all these, you can see some examples of the various internal and external factors that we include. We actually go into the modeling process. And for these, we can either pick the best performing model, and we use those elasticities, or we use sort of a weighting or a stacked approach. But let me describe each of these to you. Probably our most favorite approach is a double machine learning, short for DML. This approach gives us the most robust causal estimate. We use a 2-stage modeling method. First, we predict the sales from confounders, and then we actually predict the price from the confounders. Then as a second step, we regress the residuals of these 2 models to get a causal measure of how price changes truly impact demand. We typically create one DML or one double machine learning model per SKU. We found that DML elasticity estimates are typically the most representative of reward behavior in companies. The second one is a sort of a very basic vanilla regression process. It's your classic log-log regression where we transform sales and price into its log format. Why? For several reasons. Probably the easiest one is it's simple and it's interpretable. The coefficient of a log price and log unit model is directly interpreted as the elasticity, but sometimes it's oversimplified and not the most accurate. But for industries with large transactional volumes and lots of price variation, this can be a very good starting point. Elastic net. This is a regularized linear model that balances so-called lasso and rich penalties for the coefficients. It's actually really helpful when you have lots of features and when you have highly collinear features. It's pretty good for preventing overfitting. And in that sense, it's a sort of a step up from your basic linear regression approach for modeling elasticities. The last one is random forest. This is a nonlinear tree-based model. It's really good for handling high collinearity among the variables. And here we can't output elasticity coefficients directly, so we use something called a price perturbation. What do we do is we simulate different prices for each row of the original data, leaving all the other predictors unchanged. And we observe how the predicted sales change. And then we calculate elasticity from those percentage changes. In other words, we calculate implied elasticities from these perturbed prices and the predicted demand values. And so again, as I mentioned earlier, we compare all these 4 models. We check for error metrics like RMSE or MAPE and decide to either stick with one modeling method for a particular use case, or we use some kind of a weighted method, right? And then we actually deliver some of these as part of actionable recommendations or sort of a dynamic scenario analysis or sort of a price optimization capability. And we do that not just, again, for our own elasticities, but also for cross elasticities, promotional elasticities, and then competitive cross elasticities to understand how those different pricing actions or pricing moves impact revenue, market share, and profit. So that's just a big picture in 2 or 3 minutes. Thanks for watching. For those of you that are interested in diving deeper into our price elasticity modeling approach and get access to our 50-page white paper, along with sort of a detailed sample code for each of these 4 approaches that were reviewed, we'll include a link in the comments below. Thanks for watching.